Ladies and gentlemen, we have a request to do nomenclature bicyclic from the Fall 21 Test 1. We're supposed to draw this one and we're supposed to name this one. I believe they were both 4-pointers, 4-point questions. When you're asked to draw, that's my favorite because I think it's the easiest of the two. You draw your two dots. There's a lame looking dot. And the numbers mean we need 8 carbons between the dots, and in a different direction, 6 carbons between the dots, and in a third direction, 3 carbons between the dots. So here's 8. 1, 2, 3, 4, 5, 6, 7, 8. You like that? Random enough? Verify. 1, 2, 4, 6, 8. And then 6. I'll go in the middle. Why not? 1, 2, 3, 4, 5, 6. Oh boy. It doesn't have to look pretty, everybody. 1, 2, 3, 4, 5, 6. You know, I don't think this has come up this semester, but there's another way that can save you some time on these. It's the circle. I think you've seen it on a couple of videos. Instead of me going ziggy, 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 I just do circle and then circle and then circle. Want to do that way as an alternate answer to see if you like it? Before I do that, I'm going to put my 3 on the bottom. 1, 2, 3. But another way, here's your 2 dots. And then you can use this every time for every nomenclature problem in bicycles ever. You need 3 bridges, right? 1, 2. Oh, make it look like a happy face. Well, not really. And then you put 8 dots. Dots are carbons too. They don't have to be zigzags. Dots are carbons. So I'll put 8 up on top. 1, 2, 3, 4, 5, 6, 7, 8. I'll put 6 in the middle. 1, 2, 3, 4, 4, 5, 6, and then 3 on the bottom. 1, 2, 3. You like this one? You can do it this way. Yeah. Oh yeah. I just count your dots. Hey, easy. I like easy. I'm a big fan because this stuff's not easy. Okay. You decide carbon 1. How about on this first one? I'll go 1 right there, and on this one I'll go 1 right there. And then 10 would be this one. You know how I know that? Because I got 8 carbons between the dots. So the total is 10. When you get from 1 to 10, 1 to 10 with the 8 in the middle. So there you go. And 11 has to be up top on this one. And I can stop at 12. You know why? I don't have groups past 12. There you go. And then on this one, it was 1, 2, and then 9, 10, and 11, and then, wait, did I do that right at the top one? Yeah. 1, 2, 3, 4, 5, 6, 7. I didn't do it right at the top one. Sorry. Bad. 1 to 10 was on the top, wasn't it? What I had before didn't get to 10. Trust me. The biggest bridge was on top. Then the 11 is this one, because that's the 6. 1, 2, 3, 4, 5, 6. And then this one, I was going to go from the right and on top 10, and then 11, and then 12. And then you've got groups on 1. You want to, he was particularly interested in the sec octal, so I'll do it 2 different times. How do you draw a sec octal? The strategy is to draw octal minus 1 first, which is heptyl. Heptyl, 1, 2, 3, 4, 5, 6, 7. And to make it a sec octyl, you put the 8th carbon on, number 8, on the first carbon attached to the rings. Not the carbon itself attached to the rings, but the first carbon in the group attached to the ring. Boom, right there. Similarly here, 1, 2, 3, 4, 5, 6, 7 with the first carbon there. It's a sec octal but I have a stereo center too. What's the stereo center supposed to be? It's supposed to be F. Now, when you're doing a stereo center, you better put the missing H on. You better put the missing H on. And then you do your numbers. I'll do them in orange or blue, baby blue. We got a 1 for a branched carbon. No, we're doing the sec octal. Never mind. We got a 1 for a branched carbon here. A 2 for a carbon that goes to another carbon. A 3 for a carbon that does not go to another carbon. And a 4 for a H. And if you just connect 1, 2, and 3 with the 4 on a dash, you would get this wrong, because that would be R. So what's our other option? If you got it down to 2 options in a system, she's going to put the H on a wedge. That's our system. We developed it somewhere here, maybe, I don't know. And then make sure you put the dash adjacent. So it could be this 3 group, or it could have been the 2 group, but I chose the 3 group. And there you go. And then on carbon 10 and 12 and 12, I need cyclopropyls. We'll put the cyclopropyls in orange. 10's got one. And how do you draw a cyclopropyl? It's a triangle. Okay, I'm going to do what they call a devil's advocate. I'm going to draw a triangle, and you're going to tell me what I did wrong. There's a triangle. That's a triangle. I did what she told me. I know she knows I'm wrong. But I didn't draw a cyclopropyl, did I? What did I draw? That's a cyclobutyl. Look, that's a carbon there, what you did. Yeah. Oops. Make sure the triangle, one of the corners, is the end of that stick. That's all. There you go. And then do that again on carbon 12. And again on carbon 12. There you go. So far, so good? So far, so good. 10, 12, and 12. Those are pretty weird looking triangles, but they are definitely triangles. Stereo centers on 1 and 10 both need to be R. It's like starting a whole new ball game here. We'll go with run out of colors? No, I can't. Orange. No, I got orange. Pink. I'm doing stereo center number 1. I'm going to put this in a square so you know it's different than the other numbers. A branched carbon is number 1. A carbon that hits a branch. First of all, you can talk about branches versus non-branches when the groups are just C's and H's. There's no atoms other than those, right? So you can just keep going like this, and the one that hits a branch first, is that on the screen? The one that hits a branch first with just C's and H's is going to be a winner, isn't it? Right? And this one down here hits a branch, 1, 2, 3, 4, that's a branch, right? Over here, it hits a branch where? 1, 2, 3, 4, 5. That's going to be my 3. And this one doesn't hit a branch for 100 years. 1, 2, 3, 4, 5, 6, 7, 8, 9 is the branch. That's our 4. Same strategy as before. Connect 1, 2, 3. If it gives what you need, number 4 goes on a dash. If it gives the opposite, 4 on a wedge. It's the latter, isn't it? Because 1, 2, 3 gives S right now if the 4 is on a dash and I want R. So 4 is going on, again, a wedge, isn't it? It's going to be a long wedge, isn't it? Got to go all the way. And a dash on an adjacent. We can call this the adjacent, right? Make sure it goes all the way. Moving over to the other side of the molecule. We've got a stereo center on 10. I'm going to go with gray. We don't use gray very much. We got a 1 for a branched carbon. We got a 2 for a carbon that hits a branch on the second carbon. We got a 3 for one that hits a branch on the fourth carbon. And we got a 4 for something that doesn't hit a branch for 100 years. Okay. Did we get lucky even once? No, that's okay. Our strategy doesn't matter if we're lucky or not. If you connect 1, 2, and 3, it's an S. If the 4 is on a dash, don't put the 4 on a dash. Put it on a big wedge. 4 on a wedge. And I don't know, this is adjacent. Make sure it goes all the way. Congratulations. And I'm saving, sorry, it's on top of my drawing. PC. Where are we, dude? I didn't put my jump drive in there. Sorry about that, everybody. Don't have a jump drive in. And there you go. No. Where is it? G? No. USB drive. Huh. Okay. Quick repeat. This is the other side of the molecule. Huh. I'm pretty sure. Let's do this and then check it. Pretty bold of me to do this. I'll put that on the wedge. And number 4 on the dash. Because this goes 1 in blue, 1, 2, 3, 4. And this is a tricky one because the only way to go is that way. And guys, that is nothing but R already. It is R. Success. You see it? Yellow pen. 1, 2, 3. Okay. And the other side of the molecule, I'm pretty sure. Doesn't it look like a mirror image? I'm pretty sure that's going to go 1, 2, 3, S for the group. And over here, group there, wedge there. I'm going to go dash there. And wedge to the middle. Shouldn't have chosen blue. My dot is no longer a dot. I'll go orange. And mirror image. 4 on a dash. Group towards the middle on the wedge. Make sure there's a dot there. Although you don't need a dot. The end of a wedge is also a carbon. There you go. One or the other, please. Don't give me both. And then we're going to do this baby here. Now this one, I'll accept either direction of numbering. You can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or I will accept 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, because they both put a group on 1 and a group on 10. Or 11, I take that back. 1 and 10, 1 and 11. That's the total of the groups. Exactly the same numbering system, both directions. There is where I stop my rules. I will give you either one. We'll go with go blue for Michigan. Let's do it. So how do you say the bicyclo part? What 3 numbers this time? How do you know one of them is number 9? I got to count from 1 to 11 without counting 1 and 11. That's 9. Now up on top, 1, 2, 3, 4, 5. Through the middle, 1, 2. Biggest, middle, smallest. Has to be that order unless you want to lose a quarter of a point. It's not a big mistake. If you lose a quarter of a point, I wouldn't lose any sleep. And 9 plus 5 is 14 plus 2 is 16 plus the dots is 18. Octodecane. There you go. And what's that group on number 1? I'm pretty sure it is the first alphabetical group listed. Blue number 1, by the way. I'm going with blue. I'll put a blue one. What's the name of that group over there? This group right here. Cyclobutyl. 4-carbon ring. And what's that group on blue 11 called? There's a couple ways to name it. Please use the one that has the shape listed first. Because this has, I'll outline it in highlighter, chicken foot. It's a turt. What is my answer in pink then? Pink. Turt. Now count all the carbons. It's not just 4, it's 6. Tertaxyl. All right, if this is a 4-pointer, you've got 2.5 out of 4 for all that work. Nomenclature, you don't get enough points, but that's the way it is. Life. It's just like talking. You don't get points for talking really, but unless you can talk, you don't get points either. So catch 22. All right. So stereo centers, they're very important. That's why we only got 2.5 out of 4. Let's do stereo center on blue number 1. Branched carbon first. Carbon that hits a branch on number 3 is second. One that hits a branch on carbon 1, 2, 3, 4, 5, 6 is third. Almost wrote 6 there by mistake. And then this one that doesn't hit a branch for 99 years is number 4. Then we got a clock. And you can't, if you connect 1, 2, and 3 right now, you're wasting your time. You've got a 50-50 guess. And you just admitted you're guessing if you connect 1, 2, and 3 right now. Because any connection of 1, 2, and 3 without the 4 on either a wedge or a dash is a waste of time. So right now, double switch, because it's not on a wedge or a dash. And it's not hard to do a double switch. Copy the stereo center. Make sure you have a pen. And copy the stereo center. All bonds pointing exactly the same way they pointed before. Find the 4. Put it on the end of the dash. That means it switched with 3 from this position up here. 3 from this position here. Don't forget to switch the 1 and the 2. If you don't switch those 2 as well, you get the wrong answer. And that is definitely clockwise, right? Yes.
So about the stereo center, what's the rule in number 1, 2, 3? How do you know how to?
Oh boy. Does he have enough time before Wednesday? Because you needed about a week of practice.
Yeah, I'm like that.
But you're asking for the rules now, which means you didn't get your week of practice. The rules are you look at the atoms attached to the stereo center. Okay. Heaviest atom gets number 1, lightest atom number 4. Okay. On this particular stereo center, it's 4 carbons. It's called a tie. So you ask yourself, what's the heaviest thing on the carbon? And here it's a carbon. On here it's a carbon. On here it's a carbon. On here it's a carbon. You're still tied. Now go back to this carbon. What's the next heaviest thing? If you counted this carbon already, it's another carbon. You can't say that about any of the other carbons because they're out of carbon. You've already used those carbons to be tied to the first carbon here. So that's how we got our 1. Now, why was this a 2? Well, they're all CH2s. This is a CH2, CH2, CH2. They all have 1 C attached, 1 C attached, 1 C attached. Okay? So now you're comparing this carbon to this carbon to this carbon, okay? And they're all CH2, so they're tied. Heaviest thing here is a C. Heaviest thing here is a C. Heaviest thing here is a C. They're all tied. Now, you go to the next carbon. You're comparing this carbon, which is 3 carbons away, with this. Let's not use yellow highlighter. Let's use a different color. We've got green, 3 carbons away. There versus 1, 2, there. Which of those carbons has, well, you can't answer right away. They all have 1 bond to carbon at least. They're still tied with that 1 bond to carbon. What's the next heaviest thing off this? Another bond to carbon. You can't say that about this or this. They have H's. So we've broken the tie. That's why that got a 2. And then the 3 and the 4 is because, you know, you keep going and this hits a branch before this does. And that's why 3 versus 4 happened. And double switch was absolutely necessary because 4 wasn't on a wedge or a dash. 4 is on a normal bond. Double switch to get it on a dash. R is the stereo center. And that's not a good way to draw R. 1 is R. And you write that down here. 1 is R, comma. Carbon 11 is also a stereo center. Start over. We'll go purple. A carbon with 3 bonds to carbon is going to be the number 1. A carbon that hits a branch on the 3rd carbon is number 2. A carbon that hits the branch on the 6th carbon is number 3. And a carbon that doesn't hit a branch until the 11th carbon or 10th carbon there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number 4 is not on a wedge or a dash. Copy the stereo center. Bonds in exactly the same place they were before. Locate the 4 and put it on the dash. It was down on the bottom. It's now there. It's switched with the 3. The 1 and 2 have to switch as well. And that's an S. So 11 is S. There you go. Control save. And that's that. Big video to start with.